So we talked about the instance properties of the sketch. The next one, we got slope arrow. The point here is that if we slope a sketch, let me click on this right here. If I define a slope for it by this way, then here we can't have more than one slope, or we can't define more than one slope. Otherwise, we'll be encountered with a warning message: define a slope. Watch this. Finish. There is more than one slope defined. So only one slope is allowed. And if I select the sketch and then I choose or select define a slope, then we're not allowed to add a slope arrow. But if we undefine or remove the slope from the sketch, we can add the slope arrow. So if we add the slope arrow for the sketch like this way, it is more professional than the other one, that we can use it only for once, that we can't define another slope, as you can see. So only one of them is allowed, one a slope arrow or one a slope. Watch this, that here we got some properties. The first one is specify. If I open the drop down list, first height at tall, tail, or we can set it to slope. Watch this. We specify the slope in percentage, 15%, or we can set it to height at tail. For example, right now we have a specified 1200. Watch this. We move it upward, the height at tail, or we can specify the height offset from, or at head actually, 250. Watch this. We have moved this. Move the head 250 and moving the tail 1200. Let me increase the value. The height offset at head 500, and watch this, 500. It has been moved upwards from the level. Let me see. Let me measure the distance to the level, 500 by this way. As you can see, there is a 500 offset between the level to the head, and there is an offset of 1200 between the tail and to the level. But note that these two values, these two height offset, are independent to each other, but we just control the height offset at the tail and also at the head of the slope arrow. And also we can delete it, changing the direction by a click or by click and drag. And also we can draw it slanted by this way. As you can see, the references of the highlighted dimensions are no longer parallel. It means that we have to delete some dimensions because they are displayed slantedly. So let me return it to its default mode, and then for level at head we specify the level at the head of the sketch that has been set to default, but I can set the head or the tail to STR2 or structural 2 and the head to STR1. And as you can see, the offset is considered based on the specified levels by this way. For example, the tail and also the head that are not placed on the same levels. But if we set it to the default, the current level will be specified for them, for both. So guys, we're done with slope arrow, but I want to tell that again. If you take a look upon the log here. As you can see that we got two slope arrows, but note that this is related to roof, not floor. We can add more than one slope arrows into roofs, but only one slope arrow is allowed to floors. As I showed you, you'll be encountered with the error message. Let me delete this and then continue. Flat, here we got it. And in the instance properties, we got some options or parameters. If I select the floor, here we got the structural floor, which contains all of the architectural parameters as well. But here, as you can see, the structural floors cover all of the architectural parameters, but they contain more parameters comparing to architectural floors. Firstly, we specify the level. As you can see, it is crystal clear. The next one, height offset from level. By this way. The next, room bounding. We talked about the room boundings in walls section, and the next one is related to mass, and it is enabled when we use mass. Okay, for instance, we may have modeled something in conceptual mass. Let me open metric mass by this way. Then I want to create a surface here. Check it out. Then I want to load this into the project by this way. Check this out. Then I select the mass right here. Then using mass floors, structure 1 and 2, watch this. Then I can open the, check it out, in the 3D view. I can use floor by face and then click on these faces, specifying the type of the floor and then creating the floors. And right now, if I select these floors, it does not make difference which one to select. You'll see that related to mass is checked. So it is related to mass and indicates the element was created using biface tools. The next one is structural group. Here we check a structural if the floor is going to function as an structural floor. Note that if we draw an architectural floor, and then we can define it as a structural floor. So we just learned how to convert an architectural floor to a structural floor. Anyway, in the continuation, we got the rebar cover values for the rebars or reinforcement. Watch this, for the top face, bottom face, and other faces that we have talked about this comprehensively in Revit structure. The next one is slope, and also the perimeter. As you can see, area, volume, and elevation at top and bottom. As you can see right now, here in annotate tab, spot elevation. Then in the plan view, top and bottom elevation, I uncheck leader and then I add it. Then you'll see the top and bottom elevation of the floor. Watch this. Here the difference is 20 centimeters. Watch this. From minus 20 centimeters to 300 centimeters. If I set it to 100 centimeters, 100 millimeters, and 0 for the floor plan. Watch this. Minus 100 to minus 400. So these are some read-only values. These are not available in the older versions. And the thickness, which shows the thickness of the floor. Watch this. The general thickness actually. 425, 210, or 300 millimeters. In the next one, we can attach an image, adding a command, specifying a mark, a unique mark, and has its association specifies whether the element has a counterpart in the project or not. That it hasn't any association, but in the older versions, previous or before 2023, the analytical plane used to be created by default, but after the versions of 2022 on, we have to create the analytical plan ourselves. Here in analytical automations, if I click on it, wait for a second, here we have talked about these in a structural course in data structure. Right now I want to convert a physical model to its analytical lines. Play, then I should select the elements. For instance, I select these 3 floors, then I click on run, close. Right now, as you can see, as association is checked, it means that we have added an analytical plane, okay? That if you check the view control bar here, we got the option of show analytical model. If I click on it, then you'll see the analytical models too. So if I open the visibility graphics and then I uncheck floor, okay, you see the analytical planes that if you select them, you see the parameters that are related to structural discipline. Watch this. The structural role, the thickness, the analyze as gravity, that we got multiple options in the drop-down list. For example, two-way slab that are used in analytical sections. Again, I want to enable floors in visibility graphic. These are the items that are being covered in a Revit structure course, but as a BIM modeler, you have to be familiar with these things, and at least you should have a brief information about them. And the others are related to phasing that we talked about them before, and I will talk about them more. We are done with the instances of floors.